Hey everybody, this is Larry. This is me over Q4 of the weekly contest 485, lexicographically smallest string after deleting duplicate characters. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one definitely is a problem with a lot of traps. I don't know what's on the hidden, contest or whatever, so maybe that makes it a little bit harder to debug and fix. But in general, it is going to be, it is just going to be greedy, right? The idea behind greedy, and it is very common to these lexicographical problems, is just, especially for this one where it's removing, is just, trying to be, it is greedy, but trying to be greedy in the right way. The idea that I think about with these problems is just a sort of sorting, right? Because we have like AAB, and then maybe AAC. Well, if you're trying to remove this, well, the question is, well, if you remove this, what happens, right? Well, here you get AB, which is, of course, after AAB, so you don't want to do that. Actually, this is a bad example. I just realized. But if you have like something like BBBC, BBBA, if you remove this B, this is actually beneficial, right? So you would want to remove it, but you don't want to remove this B because then now you have BBC, and BBC, of course, is going to come afterwards. So that's kind of the idea. The core idea is this greediness of this idea of replacement, right? Like if you're removing things, do you get a new string that is quicker? I think the one thing that could be tricky, and I don't know if this is true for people, because I immediately had an idea of what I want to do, is that I do this algorithm, but I do it from Z first and then all the way to A. And why I did it this way is just because I thought that because I thought about a scenario, and I'm not quite whatever about it, but you can imagine something like ABC, and then I don't know, like BCA or something like this, or maybe even with another C. My point is that what I set the algorithm, if I just go a naive left to right, then maybe there's some weird thing that we have to revisit because of the order of operations. Like, maybe if you remove C and then B is different than if you remove B and then C, right? In this case, it actually isn't the case. But I just, in my mind, when I was reading this problem, when I was solving this problem, I thought that there is some like weird, like possible order of operation thing where if you remove characters in a different order, you may get a different answer. And that obviously, because for this particular problem, if you're going to go on greedy, there's one unique answer, right? Because there can only be one lexicographically smallest string, so there's only one unique answer, because you can have two answers, right? That are both lexicographically smallest. Then that means that there should, if you believe that on a greedy solution, there should be one unique way to there. So. And that also means that if the order matters, and maybe it doesn't, but if the order of removal matters, then if you remove it in the wrong order, then you just get the wrong answer. That's kind of what I was thinking about. And to eliminate that, I guess I did a greedy on the characters, because then now I just think about, well, the reason why, this is not a valid example, I don't have one ready. But what I was thinking about, a case in which, maybe CDA or something. Like in this case, if you remove the D first, and then you may remove the C, and then this becomes good, right? But if you remove this, if you look at the C first, and then you go, okay, C is better than D, and then you remove D later, well, maybe you don't recheck this if you're not careful and stuff like this. So then my thought process from that is just, okay, well, it will always be better if we remove the later character first, because when we remove the later characters first, then the newer characters will already be in a state where every character that's after it would already been removed. So then every character is available to be removed if a later character comes through. Basically, like in this case, where we remove all the D first, if there are characters that are quote unquote earlier than C, well, I guess I don't know why that's quote unquote. I was gonna say quote unquote better than, but earlier than C, then everything would have removed and then so forth. So almost like I sorted in that way. There's only one more thing that's a little bit tricky that I had to double check, is that it is a run of characters, right? Meaning if you have B B B B B B A and B B B B B B C, actually you don't just look at the next character, you have to look all the way ahead, right? Because here you can imagine, and maybe there's a stack based solution, I don't know, honestly, but I did it with another way. But basically here you would actually want to remove this, and then, you know, almost recursively, that's why I said stack, you remove, and this goes to BA. But in this case, actually you don't want to remove any of them, so it's just, well, no change. So a lot of B's and then C, right? But if you have an A here, then you will remove C and then do, right? So it you know, it gets out of hurry, you know, crazy in a hurry. But this is actually, I thought they may be leading to more things, but this is actually just what you think it is, which is that you group these by these B's, and yeah, and it just based on the next character, because they all have the same fate, right? Either you remove one of them or you remove none of them. That's kind of the idea. I implement this in a funky way, so, but that's basically the idea. Okay. So yeah, like I said, now that you understand the idea, here's the greedy solution, right? As I said, I go from Z to A, so one character at a time. You can actually optimize the rest of this loop, because right now it is alpha times n or 26 times n, but you can maybe make it more precise to O of n, but in that case maybe it'll be n log n, so I don't know that that's too much faster. That's why I did it this way. But for every character, I mean, maybe you could do a naive check to make sure that it's greater than 0, but that's fine, right? Is that, oh, there's also one more thing that I forgot to mention. Apologies, friends. Is that obviously here, I mean, I kind of did it, but I didn't explicitly point out, is that you have to keep one character, right? Because you could remove two things, so you have to keep one character. And really, this is just case analysis, right? Because if you have like, I don't know, BA, 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 this is Bubba, right? BC, BA. Which one, you know, let's say you're going to remove most of these, probably, maybe not this one, but then which one do you keep? Well, yeah. In this case, you want to remove this one, these two, and then maybe this one, right? And the idea here is just that, well, this one you're not removing, so you keep it. And if you keep one, if you have to keep one, and this one you have to keep because you do not remove this C. Actually, you do remove this C because of this B. So I lied. Okay, my examples are terrible. Okay, but let's just say you do remove all of them, right? Because you remove the C, and then now you have to remove this B, and then now you remove this B as well. And you remove all of them, then you have to keep one. Then which one would you keep? Well, of course, you just keep the last one, right? Because, you know, and this is and the dot process is way exchangey, right? Because you just go, okay, well, looking at these two characters, would I rather keep B or A? Well, of course, we keep the A, and lexicographically means that in a thing, we always greet toward the beginning, and as a result, we just do that, right? But let's say, so yeah, so we keep the last one if we have to, if we remove all of them. But let's say we have something like right? And then now we don't, you know, whatever, right? And then maybe there's another B and A, right? Actually, I think this messes up again. Okay, whatever. Let's just say there's another B and there's another C, right? Well, in this case, in this case, actually, now that I think about it, maybe there is some weirdness here. But in any case, yeah, if you have something like this, then you don't remove this one, and then you don't remove this one. Then now, yeah, because you already satisfied keeping one, then you don't have to remove it. But let's say these doesn't exist, then now you're also satisfied it here, so then you also don't remove it, right? That's kind of the idea. My BCBA. Well, we don't remove this C because they just released this B. But then, maybe there's some weird conkiness here. No, you do remove this C because it's B. But if you have C and then D, well, D, you remove the D and then you remove the A. I don't know. Maybe this case doesn't come up. I wrote it in a case such that if there's a later thing, it just takes anyone. But I guess maybe it's always the last one because if there's one that removes it, then it just keeps on going, right? There's no stop. So maybe the keep is always on the last one. I mean, I didn't write it in a way such that I rely on it, but now that I think about it, maybe you always keep the last one anyway. Yeah, maybe you always do keep the last one, huh? But yeah, that's basically the idea, is that you just keep track of whether you already kept one or not. I mean, you may kept multiple anyway, right? So here, that's what the keep is for. Remove is just remove index. And the reason why I keep it in an index is just so that we could loop through this without worrying about indexes, right? And here, this part is a little bit wonky. Basically, I just keep like a sliding window. And the reason this index is written like this is because we basically either look at the next index, or if the next index is the same character, you keep on going until you see the next character that isn't the same. And then if you kind of think about it in terms of things, it'll catch up, right? So that you do keep it constant time and look at it one at a time. That's basically what this does, because otherwise you do not update right. And then yeah, if we're at the end of the character, then we always remove, because if you have like duplicate characters at the end, then you always remove, because a shorter string is always preferred, right? Keep in mind that you still have to keep one, but yeah, but basically if we have not kept one, then like if we haven't been forced to keep one, then we just remove the removal of the last one, so you keep the last one, and that's it. And you convert it to a set, and then you just kind of remove it. This is going to be O of 26 times n, or O of alpha times n. This, despite how it looks, is constant amortized. And yeah, that's it. That's what I have with this one. Let me know what you think. Just pretty greedy, I think. That's basically the idea. And just thinking through a lot of case analysis and making sure that it handles it. That's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in contest next. And server issues, also maybe unrelated, but I don't know. But that's just me dumb. Alright, string s, lowercase, any operations, or any number of operations. Choose any letters that at least twice, and then delete them. Return the lexicographically. Smallest that could return that way. So you never subtract a. So then it's just like one of those. You remove if there was a previous, if there's smaller letter afterwards, kind of thing, right? So yeah, I mean, I don't. Oh, I I guess the tricky thing is that you can remove. Okay. What if I do it one letter at a time instead of index? So then you have sort of set. And then everything goes before, right? Because everything that is before Z would go anyway. So then, okay, so then I think, okay, so then what's the right way to write it? It's just that it is smaller than the next one. Right, is that it? If current sub I is oh. Wait, I assume that you always remove the one afterwards, but no. Do you always keep the latest one? Well, yes. Because of greedy. Right? So you keep the latest one if you have no choice. If you remove, or if you don't, if you have an earlier one that you haven't removed yet, then you could delete it anyway, right? So, okay. So if this is equal to C, in theory you could probably even jump ahead, but 26 times n should be fine. If not, then we have to optimize, but that's okay. Yeah, not worth doing. A lot of complications. If the next letter is smaller, otherwise, yeah, then now we remove I. Okay, so we've kept one, right? Then we can remove everything. Otherwise, if we have not kept one, then we have to keep at least the last number. Right? I have to think about how to handle. Like if you have all B's. Okay, let's see here. I have to handle this a little differently actually. Because you have like this, then actually you should remove all, well, yeah, you should remove all of these. But the way that I do it, I don't think I actually check. This is annoying. I mean, I don't think it's hard, but it is annoying. How would I do it? Because you would also not, if it's something like this, you would actually not remove any of these B's. So you have to kind of figure out how to jump ahead. I don't know actually. Let's see if this works for. Actually, I don't know. The examples are kind of weak. Something like this, right? Leetcode's having issue. I don't know. I don't know why Leetcode's having issue. I mean, it is what it is, but it has to be the time down. You know, I don't know. I guess that's why I struggles about, right? But I mean, this isn't right yet anyway. Thanks, Leetcode. Premium Leetcode. Just so that I can even get a result. Is it me? Can I go on websites? No, I mean, it seems like I can go on websites. So just Leetcode. Oh well. How do I handle this stuff? It should be good for the first two, I think. Or at least if the input matches what Nico does this sometimes, but he just forgot that, you know, I didn't do anything, right? And now I have to run it again. But yeah, but these are not right, of course. This has to keep going. I'm also trying to think whether like this is the right way to fix it. I mean, I could definitely do it, but something like this. But we want to skip doing it again, right? Doing something like this. There is a thing though, because I think this is a case too where if it's just this, you want a shorter one, so you just remove all of them, right? That's true for no matter what, but it's hard to test, or like the way that I write these problems is like more iteratively, and it's hard to iterate when the server is not up. I might just, I don't know, do it offline or something. How much time do we have left? 59 minutes. We still have plenty of time. It's just great. Don't even show up. So that's why. I mean, this looks okay. ACCP, CPA. This isn't right because you would rather. It should be CAB. Why is it okay? So the C's, it removes the C, one of the C, it doesn't matter which one. Okay, so then CBAP, right? So this isn't right. Okay, why is it not right? It goes through it. This should remove this. Right, and then now it should try to remove both of them because this one should the last character should try to remove it, right? What's it called? C remove. Okay. 1 and 3. Oh, because do we keep the last one? Why would I thought I'd keep the first one. Wait, do I? No, what? This may not exist, but oh, this is a set object. Okay, fine. This for now. It's such a hack, but okay. CPA still wrong. Okay, 1 and 3. Then we only kept 3, right? Why? Huh? Yes, crazy technology cannot do it. Okay, so you removed. Wait a second. Why is this different from pop? We popped the 3 to, and we removed 1, right? Wait, but so we removed 3. Okay. I mean, this is expected, but that's why I had it as pop before, right? Oh, because it was a set, so I think pop meant differently because I converted to a set by accident. Well, not by accident, but just okay. I mean, I guess it's good to catch. Oh, oops. It's good to catch. I don't know. Very dumb today. I am. And Leetcode doing stuff like this is not great. Alright. I think this is right. Alright. I mean, probably missing something, but at least it fits. You know, we gave it a try. Oh, that's actually surprising. Of all the silly mistakes to make, I didn't, you know, Q4 was the one that I didn't do. But, alright. Thanks for watching, everybody. Hit the like button, hit subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.